So today we're not going to do a iClicker quiz for the first time because the first section, they were still having trouble with the Wi-Fi. So we decided it wasn't fair, so we'll have one tomorrow. But today I wanted to go over empirical formula. So hopefully all of you watched the empirical formula quick tutorial. And for tomorrow, you need to watch the limiting reagent quick tutorial. It's not done yet, so don't look for it. I'm about to it's processing. So in the background, it's processing. So it'll be done probably shortly after class, and I will post it and you guys can watch it. But please watch that before tomorrow. Today, in the first section, we actually went over a bunch of problems, like 3 problems, 1 of percent composition, 2 of empirical formula, and then we actually they wanted to go over a limiting reagent problem, and we had time, so we did it. So hopefully we can do the same thing. Before we start, I want to ask you guys if you guys have any questions, any general questions, or are you guys good? Remember that there's a study session tonight. If you guys are more than welcome to come. But any questions that you guys have? Oh my goodness.
No.
Does anybody want to say hi?
Off the top of my head, no.
Say hi, how are you? Have a chat. Okay. Well, I am going to start then. And I'm going to need an engagement today, yes? So talk. If not, I'm going to pick on you. But the first problem is from the book. Actually, 2 of them are from the book. But the first one's from the book, and it's so if you have your book, and it's the book, not the free book, right? So if you have your book, it's number 41 in the back of the chapter. So 3.41. All right, so let me share my screen. And it's a bit of a paragraph, so I'm going to read it slow, but you got to pay attention if you don't have the book. Okay, so I'm going to put you guys down. Okay, so it's 3. Oh, that's too thick. Hold on. Let me change here. That one. That's better. 3.41. Okay, so listen carefully. This is what it says. Cinnamic alcohol. Cinnamic sounds like cinnamon, right? So it's something to do with that. But anyway, cinnamic alcohol is used mainly in perfumery, particularly in soaps and cosmetics. Its molecular formula is C9H10O. First part of the problem says calculate the percent composition by mass of carbon, hydrogen, and oxygen in cinnamic alcohol. Why are we doing percent composition? For the same reason that I did percent composition before the empirical formula calculation in the quick tutorial. You have to understand percent composition so it could help you, easily do the empirical formula calculation. So let's do this first. Hopefully it'll be quick. Can you guys tell me how I would find can you tell me in 2 words how to do percent composition? Think about that in 2 words. How would you explain to someone percent composition? In 2 words. I said it like
molar mass.
No, not molar mass. Percent composition has something to do with molar mass. I mean, it does, but the word itself, percent composition. If you were to describe mathematically to anyone about a percent, how would you describe it in 2 words?
Part over whole.
That's it. Good job. You win the prize. So no prize, but part over whole. That's exactly what it is. Okay. So what is the whole in this situation? How would I get the whole?
You would take the mass of each element and then add them.
Right. So it's the whole molecule, right? So can someone do that for me quickly? And yeah, I'm going to need you guys to get your calculators. We're going to do lots of work today. So lots of calculation. Can someone multiply 12 times 9 plus 10 plus 16? Okay, I'm going to start picking up people.
34.
It cannot be 34. It's 12 times 9. So how can it be 34?
I said 134.
Oh man, I'm so sorry. My bad. 134. And what units would that be? Squids? What did somebody say something? Sorry.
Grams of C9H10O.
Just grams? This is the is this not the molar mass?
Oh, grams over mole.
Yes. But you have to give me a unit every time you give me a number. You should know that by now. A unit, and the unit here is either AMU, because you could have said AMU, or grams per mole. And the one that I would like you to do from now on is grams per mole, because that's the one that's the most useful. So not squids, grams per mole. Cool. All right. So that is the whole. That is the whole in the part per whole equation. So now let's do the parts. If I wanted to do the part of carbon, what would I put? How would I do that?
The molar mass of the 9 carbon atoms over the total molar mass.
Okay, Isaiah, you still sound really low. I don't know what's going on. It might be your computer speakers. But anyway, what is 12 times 9? Can you tell me that?
108.
108. So tell me what I would do with this number, 108, and do what then?
Over the 134.
Over the 134, perfect. And then times 100, right? Because I want a percent. So can someone do this for me? And this is for carbon. So for hydrogen would be 10 over the same thing times 100. What's 108 divided by 134 times 100?
I got 80.59 instead.
80.59. And that's what, percent?
Yes, percent of carbon.
Okay, percent of carbon. So here I want to point out, since you guys are getting so stressed out about the sig figs, and I always tell you to stress out about sig figs, there's 3 instances when you don't have to worry about significant figures. And it's when you're reporting a percentage, for example, like we're doing right now. So even if you gave me 80.6 or 80.5, well, you do have to round, but 80.6 or 80.59, I wouldn't take off. It doesn't matter. Percentages, you don't have to worry about significant figures. Another instance is when you're dealing with money, obviously, right? We have cents and money, if the question is asking you for a dollar amount or whatever cents, don't worry about sig figs in the answer. Another instance, there's 3 instances. Another instance is temperature. So if you were reporting a temperature, which we haven't done yet, but as we get towards chapter 5, we're going to start working with temperatures a lot. But temperature, you don't have to worry about sig figs. So those are the 3, all right? Percent, money, and temperature. Okay, so what's the answer for hydrogen?
7.46%.
7.46%. Awesome. And before we do the oxygen, do we have to do this method that we've been doing, or is there another way that we can figure this out?
You can subtract from 100.
Okay, so add these up, whatever that is, subtract that from 100. Why? Because it should all add up to 100%. So what is it? What is oxygen?
11.94.
Okay, so hopefully if we did our math right, all of this adds up to 100. That is it. That is how you do a percent composition problem. So I'm not going to spend too much time on that. It's easy peasy. But do you guys have any questions or any doubts or something you want to comment? Anything? Okay. So the second part of the problem asks how many molecules of cinnamic alcohol are contained in a sample of mass 0.469 grams. So let me write that down and then I'll read it again. 0.469 grams of C9H10O. The question is again, how many molecules of cinnamic alcohol are contained in this much grams of the sample? Can someone other than the people that have been talking tell me what to do?
You would have to put the mass that we just got, which was 134 grams of C910O.
Where
I
on
mean
the bottom?
CH10O. Yes.
Okay. So yep, 134 grams of C9H10O. What goes on the top?
Avogadro's number.
Wrong. Sorry. So remember, Kennedy, remember the flow. Remember the flow, right? You can't go straight from grams to atoms.
Yeah, you go to moles.
That's right. That's right. You got to go through moles always first. So what goes on top then? Tell me exactly what goes on top. The number and the unit.
Wait, are we trying to? Oh, okay. 1 mole of the
C9H10.
yes.
Right. And Kennedy, since you're the one who's talking, what is this called? That little fraction that you just did, what is that called?
Molar mass.
That's right. That's right. Okay. So we're on the same page. Okay. So now that we're in moles of the unit, where do I need to go? What else do I do? What's the next? What goes on the bottom of the next fraction? Somebody else, if Kennedy doesn't want to keep on.
Oh, I'll keep going.
Okay, go ahead.
Would you put another 1 mole of the C9H10O?
You certainly would. C9H10O. And then what goes on the top now?
Avogadro's number.
Aha. Yes. Now Avogadro comes into play. And they wanted what? They wanted molecules. So we would put 6.02 times 10 to the 23rd molic of C9H10O. All right. So I don't care about the answer, but that's how you would that's how you would do it if you multiply all that out. How many sig figs should your answer have, whatever that answer is?
3.
That's right. So it would have 3 sig figs, whatever the answer, blah, blah, blah. You get a good grade and we're moving on. Anybody have any questions on that?
So when we write the mole in terms of molar mass, is it necessary to include the 1?
Just for your second exam, yeah. Do that. Practice it like that. So as I get more confident that you guys know exactly what you're doing, then no, because sometimes I don't even write it, to be honest. But you're still learning, so yeah. Please do it. I'm not going to take points off, but I'll ask, and if something goes wrong after that, then I'll kind of blame it back on the fact that maybe you didn't understand that it was 1 mole. So yeah, just do it, please. Any other questions?
The only reason I asked was because I was thinking of another compound unit like density, which is grams over centimeters cubed, and usually you don't write 1 for the centimeters cubed. But I
You're
understand.
absolutely right. You're absolutely right. You're absolutely right. And I usually do not write grams, the molar mass. I usually look at how I wrote it up here, right? I don't write, when I did the mass up here, I don't put grams over 1 mole because it's understood. And you're absolutely right. But the reason I'm asking you to do it is because not everybody is as comfortable with this as maybe you are. So it's if you have the 1 mole, then that maybe the next fraction, it'll help you understand what the next fraction should be as well, the bottom of the next fraction. If you feel comfortable enough, you don't have to. But if you're still learning, then I would, just to get yourself, I don't know, trained. But is that okay? Is that cool?
Yes.
Okay, cool. So any other questions on this? All right. So I'm going to do another problem. And this one is actually going to talk about empirical formula. This one's 343. So if you have the book, it's 0.43. Number 43. Again, it's a paragraph, so you just have to listen. Allison, and not the name, it's spelled like this. So allicin is the compound responsible for the characteristic smell of garlic. Cool. An analysis of the compound gives the following percent composition by mass. So they have carbon is 44.4%, hydrogen is 6.21%, sulfur is 39.5%, and what's the other one? Oxygen is 9.86%. Okay, so what they want, well, we haven't even heard the question. Hold on. The question is, calculate its empirical formula, and then there's other stuff, but that's the first thing. Calculate its empirical formula. Okay, so for those of you that watched and have studied and have read, you know that in the quick tutorial, I asked you for the steps, right? Because it's important. If you understand the steps, then you should know how to do every single empirical formula calculation problem. What is the first step? Can someone tell me?
Convert
Convert what?
percentage to mass to
Yes,
grams or something.
right. And here's a question that I have for everyone. Why can I can just convert them straight to grams, right? Like if I have 44.4%, why is it possible that I can go ahead and just say, oh, it's 44.4 grams?
Because a percent by its nature is just a ratio, so it doesn't have units. You don't have to worry about converting.
No, yeah, you're right, but that's not what I meant. Maybe I didn't ask it correctly. Why are you able to just straight up go from okay, maybe this is the way I should ask it. How do you know that 44.4% will equal 44.4 grams? What are you assuming?
That they add up to 100%.
Exactly. So you're assuming that you have 100 grams. And what you said is absolutely correct. What you're assuming that they add up to 100. So this is a warning, okay? Some problems, they will not add up to 100. Okay, so maybe what they'll do is they'll give you 3 out of the 4. You know what I mean? And they'll say, okay, so you have 44.4, 6.21 hydrogen, 39.5, and the rest of it is oxygen. So you would have to figure out how much is the rest of it. But they will give you enough information that you can figure that out. That's why I asked you up here, is there another way that we can find the percentage of oxygen? Yeah, we can if we just subtract it from 100. So can somebody make sure that this adds up to 100? Can someone do that? Let's not take it for granted. Hello, class?
It's 99.97.
Okay,
So
and that's close enough. That's close enough. So that I will take that as 100. So since we understand, oh my goodness. So if we understand that, let's go ahead and start writing 44.4 grams. I've got 6.21 grams carbon, hydrogen. What's the next step?
Convert to moles.
Okay, well, can you tell me how to do that then? Let's do it for carbon. So I have 44.4 grams of carbon. How do I convert to moles?
You're going to put 12.01 grams of carbon on the bottom.
Okay, what goes on top?
1 mole.
Okay, what is this little fraction called that you just told me?
Molar mass.
Very good. You sound like you're bored. That's good. That means that you know it. That means that you got it. All right, good. That's exactly what it's called, molar mass. So somebody start doing that calculation for me. Obviously, I do the same for everybody else. So it would be 1.008 grams of hydrogen goes to 1 mole of hydrogen. Sulfur is 32.07 grams of sulfur is 1 mole of sulfur. Are you guys at all?
Dr. Trene?
Yep, what's up?
The rest of the question, it says that the molar mass of the compound is 162. So we won't be able to answer the second part if we use 44.4 grams because it doesn't equal 100, equals 162.
What?
So
No, we will be able to answer the second part because we do that with the molar mass. This is just the grams of the carbon atom. that you're relating it to 100%. But that's why we convert it to moles, so that we get the molar ratios. You know what I mean?
If you say so.
I do say so. I promise. So can you guys tell me what's the answer to the first equation, the first calculation, 44 divided by 12.01?
3.696 moles of carbon.
3.696. Is that all it gives you, or does it give you a little bit more?
It gives me more. I just didn't know where to stop.
Give me maybe one or two more.
3.6969.
Oh, you cut out. 3.696991.
So 91.
Okay, that's good. What about the hydrogen?
6.1607.
That's good. Moles of hydrogen. What about what's this guy? Sulfur. Is anybody impressed that I knew all of those molecular weights off the top of my head? Somebody shake their head.
Good job.
Yes,
Awesome.
thank you, because that's impressive. But I have been doing this for freaking 10 years. Anyway, go ahead. What's sulfur?
I got 1.20795.
That's perfect. Moles of sulfur. And then what do we do? What's the other one? Oxygen. That's the last one.
0.61625 moles of oxygen.
0.61625 moles of oxygen. Okay. Now, look at what we've done. We've taken the percents, we've converted them to grams. All we did is then convert them to moles. Now, what is the next step? What do you do from here?
Divide everybody by the smallest mole.
Can you tell me why you would divide everyone? I mean, take a step back, right? And remember what this problem is. This problem is an empirical formula calculation, right? So why do you think we divide by the smallest?
Maybe because it's the smallest ratio, or
That's
like the
exactly right. Yeah, that's exactly right. If you remember from the quick tutorial, I gave you N4H8, right? And if you want the empirical formula of that particular compound, you divide all of the atoms by the same multiple. So it would be NH2, and that's what most of you got. So that's what we're looking for. We're looking for the smallest whole number ratio of how those atoms come together. So that is why I need to divide everybody by the smallest one to get the smallest whole number ratio. So the smallest one here is who? Oxygen, right? So we divide everybody by 0.61625. So can you guys do that for me? Divide everybody, and this is obviously 1. The oxygen's obviously 1. But can you divide and tell me what those answers are? Hello?
For carbon, I got 5.999.
999. Awesome. What about hydrogen?
9.997.
You said 9.997?
Yes.
Okay, cool. What about sulfur? My children, hello?
I got 1.9601.
1.9601. Are you sure?
Yes.
9601. Maybe, is this correct? What's 39.5 divided by 32.07? Can you check that? Did I write that answer down correctly? 1.20795?
I got something different.
Yeah, you should have. What is the answer then?
I got 1.2316.
What? That's even worse. No, guys. Okay, am I gonna have to bust out my calculator? My goodness gracious. Okay. 39.5. Did I write those down correctly? Yes, 39.5 divided by 32.07. Okay, so this answer is not 1.20. Oh, you're saying you got 1.2316 for this, for the blue answer. Is that what you meant, Camille?
Yes.
Yes.
Okay, okay. Yes, that is correct. Okay, so right here, this is a great example. Great example of why. Remember how in the quick tutorial I said do not cut off your numbers? Do not do that. Because 1.96, even though it might seem really close to 2, it's not as close as it should be. Right? Like right at this point, let me change my color. At this point right here, theoretically, that is the empirical formula. That is it. But you have to be extremely close to an integer to say, oh, no, that's 6 for carbon, and that's 10 for hydrogen. The 5.999 is close enough to 6 that I can say that's 6. But 1.9601, that's, what? That doesn't seem right. So you have to go back and make sure that you're doing your calculations correctly up before that. And that's why it's also important that you don't cut off your numbers. If you do, something like that will happen and you'll get all confused. So if it's now in the right number, 1.23168, what is that divided by 0.61625?
1.9986.
Aha. Okay, there you go. So sulfur, sorry, 1.99 something, whatever, 99. That's close enough to 2. Oxygen is obviously 1. Okay, so this is it. This is the answer. I mean, at this point, if all of them are integers, which we're going to convert them to right now, then that is your empirical formula. That is it. So the empirical formula for this is C6H10SO. S2O, my bad. S2O. That is it. Okay? So do you guys have, and I'm going to do a problem now that, like in the quick tutorial that you had to multiply, I'm going to do one like that right now. But does this make sense to you? Do you understand how to do this? And if you don't, ask a question.
Yes.
Yes, but I have a question.
Okay.
When we get the answer for the blue, for the moles, do we write the whole thing out or do we stop at a certain number?
You see what I did. You saw what I did. So I don't cut them off. And by that, if your calculator shows you the whole freaking screen is full of numbers, you don't have to do the whole freaking screen. Okay. But give yourself like 4 or 5 digits. Don't be quick to cut them off. How many freaking microseconds are you saving yourself by writing 3.7 for carbon versus 3.6961? I mean, so I don't know, there's no right answer. I can't tell you, oh, always put 5, but just don't cut yourself off, right? Because some of the times you're going to do this and you're only going to get 2 digits. Like, let's say, whatever you're dividing just gives you 2 digits and that's it. You can't do anything about it. But if it gives you a bunch of digits, give yourself like 4 or 5. That should be good enough. Because what you don't want to do is you don't want to happen exactly what happened to us. When I heard the 1.96, I was like, oh, that doesn't, it should work out nice and perfectly, okay? So if it doesn't, then you probably should go back and look at it. Okay, so that is the first part. We figured out the empirical formula. That's the lowest common ratio of that compound. What is the second one? The second part says, what is the molecular formula given that its molar mass is about 162 grams? So given that this thing weighs, that the molecular formula weighs 162, I need to find out what the sorry, my bad. Let me restate that. Given that the molecular weight of the molecular formula weighs 162, I need to find out how many times the empirical fits into the molecular. Does that make sense? So this is your empirical formula. And I need to see what the molecular formula is if they give me this molecular mass. How do I do that?
Find the molecular mass of the empirical formula and then divide the empirical formula by the,
Yep.
divide the molar, the big one by the small one.
Got you. I know what you mean. So can someone tell me what this weighs? How about you, Justin, since you said that we couldn't figure this out?
Oh, it weighs 162.3 if you use, yeah. So it's
Okay.
basically the same thing.
So it's basically the same thing. So if you weigh this out, the empirical one, it should be around 162, whatever, 0.3, whatever, but that's close enough to that. So that means that the empirical formula is the exact same as the molecular formula. And I told you that there are a couple of compounds that do that, you know, like H2O, that is the empirical and the molecular formula of that compound. So there are some that do that. There are other ones that don't do that, and you do have to do this little calculation to see how many times it fits into the molecular weight, okay? So I want to do, any questions? Or if not, I want to do another one. All right, so I am going to, and here it is, because I found it online. It's at number 1 right there. So it says, an oxide of chromium is found to have 68.4% chromium and 31.6% oxygen. Easy. So let's find its empirical formula. Let's do that. So 68.4 chromium. Let me change colors. 68.4 chromium. And then what was the other one? 31.6 oxygen. So that was percent, but I'm going to go ahead and just convert them to grams because we can do that. And what's the next step? Quick. Yep. Can somebody tell me what the molar mass of chromium is? Because I don't know that one.
52.
52 by itself or just 52 something?
52 grams.
Okay, no, but what I'm saying is it 52 exactly? Where's chromium?
Yes, it's 52 exactly.
Okay. 52.00 grams of chromium is 1 mole of chromium. And then oxygen is 16. Can you guys do this calculation for me, please?
$1.975.
For chromium?
No, sorry. No. I thought you wanted us to do the second one.
Okay, sure. 1.975 for oxygen.
And chromium is 1.315.
1.315 what?
4.
4. Is that all is that the 975, is that all it gives you, Camille?
That's everything.
Okay. All right. So moles of chromium. Okay. So now what's the next step? Come on, guys. Same freaking protocol. What's the next step?
You divide by the moles of oxygen.
The moles of oxygen. Why would you divide by the moles of oxygen?
Oxygen. I mean,
Okay. So divide by 1.3154. Everybody, what do you get? So for chromium, what's the chromium one and what's the oxygen one? Obviously, the chromium is 1. What's the oxygen one?
1.5.
Okay, is that all? 1.5?
Yes.
Okay, so this is a problem. I hope everyone understands why is this a problem? Can someone tell me?
Because you can't round 1 all the up from the 5.
Well, and you can't have a decimal of a mole ratio. That's the main problem, right? So you can't leave it like this. So you have to take these molar ratios that you have and multiply it by something. I don't know what, it depends on the decimal that you get, but this one is 1.5. So I would have to multiply this times what to get it to a whole number?
2.
That's right. If I multiply this times 2, I will get 3. So they will become oxygen 3. But if I multiply this times 2, then I got to do the same thing to the other guy. So then this would be, instead of CR1, it'll be CR2. So the empirical formula of this problem is CR2O3. Do you guys understand what I just did?
Yes.
Do you understand why we did it? And do you understand that it's not always going to be times 2? It could be times 3. If it was, instead, if I had a, instead of 1.5, I had 1.333, right? I would have to multiply that times 3 to get it to a whole integer. And realize that you have to multiply everybody by the same number. You can't like multiply this dude by 3 and then this dude by 5. No. Everyone the same. Everyone same. So you guys get that? You're good with that?
Yes.
Okay. So if you're good with that, then we can do more of these empirical formula type problems, and you can find one for me, or I can do a limiting reagent problem. What do you guys want to do?
Limiting reagents.
Okay, let's do limiting reagents. And then I have one that I've picked out for you. And we didn't get to finish because limiting reagent problem takes a while, especially when you're teaching it. But at least you'll be a little bit prepared for what you're going to see tonight in your quick tutorial. Okay, so it's number 3.94. It's 3.94 in the book. And again, it's a paragraph. So first it says disulfide. Okay, let me say it slowly. Disulfide dichloride. Can you tell me what that is? Tell me what the molecular formula is. And don't look at the book if you have it. Try to do it with your brain. Disulfide dichloride.
Two sulfurs and 2 chlorines.
Okay, so
S2Cl2.
Thank you very much. S2Cl2. Good. So remember that this is how you're going to see things in your exams from now on, right? Like I'm going to tell you stuff in words. So you got to really, really get good at this like nomenclature stuff, because then you can't even do the problem. So anyway, disulfide dichloride is used in the vulcanization of rubber. I absolutely love that word, by the way. Vulcanization. Anyway, the vulcanization of rubber, a process that prevents the slippage of rubber molecules past one another when stretched. All of that sounds like I don't need any of that information. Okay, so the book actually gives you the reaction, and I'm going to give it to you, but I'm not going to give it to you balanced. So it says it is prepared by heating sulfur in an atmosphere of chlorine. So then they give you the the reaction, which is S8Cl2, because it's in an atmosphere of chlorine. This is gas, and that goes to S2Cl2, and this is also a liquid. Can you guys balance this for me? Because remember, now every time you see an equation, you gotta balance it. You can't take it for granted. So balance it for me, please.
Put a 4 in front of chlorine, and then put a 4 in front of disulfide. Disulfide.
Disulfide. Finish it.
Oh, dichloride.
Correct. Good job. Okay, so that's it. Balance. Great. Now we can actually figure out what the hell the problem is. Okay, it says, what is the theoretical yield of this product of S2Cl2? What is the theoretical yield? So let me just write that down. They want to know theo yield. Theo yield. Okay. when I start out with 4.06 grams of S8 and 6.24 grams of Cl2. They have other questions, but let's do this first. I need to find the theoretical yield of this product. This is not hard. Let me for real, take a step back and realize that you know how to do all the steps, you know how to do them, because all this entails is moles. Again, right? Mole to mole ratios, grams to mole, it's the same freaking thing. It's just now I'm asking you to go to a specific person in a reaction. Okay, so I need to find out how much product I made. That means that for me to do that, I need to know how much I start with. That's why they give you the starting material of both of them. I need to take these starting materials, both of them, and take them to S2Cl2. So that should be simple for you guys. So I start out with 4.06 grams of S8, and I want to get to S2Cl2. Can someone help me do that?
You said we're getting to what?
So the question is, they want to know the theoretical yield. So theoretical yield is how much product is yielded, right? So at the end of the reaction, how much can I weigh out? How much do I get? You know, so I need to get to that guy. I need to get to S2Cl2. So I can find out how many grams of the product I made. So I need to get to S2Cl2. Can you help me get there? Can someone help me get there?
Use the molar mass.
Okay, so use the molar mass of what? Complete sentences, Camille. Let's go.
So on the bottom, it'll be grams of S8, and on the top it'll be 1 mole of S8.
Grams of S8. This is 1 mole of S8. Now we're in moles of sulfur, 8 sulfurs. Then what do? Let's just go ahead and create the path. Forget about the freaking molecular weight for right now. What's the next step?
Put 1 mole of sulfur 8.
Okay, and then
Then you would put 4 moles of disulfide chloride.
disulfide, not sulfate. I think I heard you say an A there. So yes, very good. And where did you get these numbers? This 1 and the 4.
The reaction.
That's right, the balanced reaction, which is why we have to balance it. Okay, good job. So now we're in the person that we need to be, but we need to find out grams, right? So we're not totally done yet. We're not totally done yet, but let me ask you to stop here and let me ask you a question. What if the question asked this instead? Can you just tell me who the limiting reagent is? So remember, this is a limiting reagent problem. To kind of give you a background, reactions don't go on forever, okay? You obviously start out with with material, and when that material finishes, guess what happens? The freaking reaction stops. I mean, it doesn't necessarily stop, but it stops going forward because you don't have any more starting material. So understanding that, you should understand that there is something that makes it stop. It's the dude that runs out first. So that's what we're trying to figure out. We're trying to figure out which one of these guys, that sulfur or the chlorine, is the dude that makes the reaction stop going forward. That's the whole point. Okay, so the question that we have asks, how many grams of product do I get? Which is, in other words, called the theoretical yield. But instead, I want to take a step back and ask you, if the question instead asked, just who is the limiting reagent, would I be able to stop at moles? Let me ask it one more time. We can't stop at moles right now because we have to go to grams because they want to know grams. But if the question asked who, I don't care about how much I make, I just want to know who is the limiting reagent, would I be able to stop at this step?
Yes.
Okay, why?
Because This is like really crazy. It's like a theory, but like, you know how there's 4 moles of S2Cl2 on top and how there's 1 mole of S8 on the bottom? Like if you were to switch the sulfur with chlorine, you would have 4 moles of chlorine on the bottom, and you could tell like the 4 on top of the 4 would make 1, and the 4 on top of 1 would make 4. So like,
so you're on the right track. I mean, I think you're taking the scenic route, but you're on the right track because the answer to my question is yes. You can stop at moles because moles tell if one of the guys has less moles than the other guy, if you make 2 moles of product with this one that we're doing right now, let's say you get 2 moles, right? But then when you do the same thing with the chlorine and you only get 1 mole of product, you can tell me who is the limiting reagent because one of them makes less amount of moles. So do you understand that, or did I confuse you guys?
it makes sense.
I hope it makes sense. So it depends. My point is that it depends what the question is asking. You don't necessarily have to go all the way to grams every single time. If someone asks you, just tell me who the limiting reagent is, you can stop at moles because moles tells you that information. But this dude, this particular problem, asks something specific. He wants to know in grams, because it says it in grams, can you tell me how much product I make? So we have to go all the way to grams. What the next step is obviously going from 1 mole of the product, it's S2, Cl2, to grams of the product, S2Cl2. We actually do have to do this calculation because we need to find the grams. So somebody tell me what S8 is. What is sulfur? Sulfur is 32.07 times 8. What is that?
32 point.
Yeah, times 8.
256.56.
Okay, 256.56. And what's this guy? S2Cl2. Hello, guys. Oh my God. Okay, for real? Amara, Terry, Evan, Kezia, Isaiah, Andrew, like, where are you guys? Hello?
I got 135.04 grams of S2Cl2.
135.04. Okay. That sounds okay. Sounds reasonable. So can someone now do this equation, this whole calculation? So all it is 4.06 times 4 times 135 divided by 256.56. Can you please tell me what the answer is?
I got 8.54.
8.54?
Yes.
That's all? No other digits? 8.54?
8.5479.
Yeah.
Okay. And would that be pillows? Fanny packs?
Grams.
Grams of disulfide dichloride.
Thank you very much. You guys think I'm silly for asking that, but you'll see it'll help you one day. All right. So that's how much product we get from the sulfur. We have to do the same exact thing with the other guy. That's the whole point of the limiting reagent problem. I'm not going to ask you over and over again, but it's literally writing down exactly the same thing, except now we start out with 6.24 grams of Cl2. So I would go from grams of Cl2 to moles of Cl2. This is 35.45, so this is 70.9. Now I do a mole-to-mole ratio, right? So what would be the mole-to-mole ratio? I do the mole-to-mole ratio from moles of Cl2 to moles of S2Cl2. What is that? What ratio is that?
Wait, are you asking for how many moles or what that is called?
Nope, that's not called anything. That's just called the multimole ratio. So yes, I'm asking how many moles?
4 moles of dichloride and 4 moles for disulfide dichloride.
Exactly, because the balance reaction says it. And then use molar mass. 1 mole of S2Cl2 is 135.04 of S2 grams of S2Cl2. So now you got to do this problem. So do this calculation, see how much that gives you. And guys, I mean, it's just 6.24 times 135 divided by 70.9. You don't have to do this. This is 1 over, it's 1. So you don't even have to multiply that. What is the answer? Come on.
I had 1.9046.
1.9046 grams of S2. So is this, did anybody check these answers, the 8.5 and the 1.9? Are these correct? They seem a little different than from what I got. Maybe the first section was incorrect. But anyway, let's just say this is the correct, these are the correct answers. Okay, so now look at this. You've got, yeah, this seems wrong. This answer, these answers seem wrong, or the first sections were wrong. But
I got an answer.
Go ahead.
I got 11.96
For
94 for the dichloride.
You got 11.96.
Yeah, 11.9694.
Okay, no, I believe that's fine. It's just
I got that too.
You got that too? Okay.
I forgot the 6.
Okay, so 11, but it's 11, not 1, because you had told me 1, Justin. So it's 11.
Yeah, I forgot the 6.
Okay, 11.9694, I think I heard. Okay, so when you look at these two answers, who is your limiting reagent?
Sulfur.
Right, S8 is the limiting reagent because this guy is smaller. You have a smaller amount of this guy, right, of the product. And who did this come from? This came from the sulfur. So that means that sulfur is your limiting reagent, which means that the other guy, the chlorine, is called your excess. That's the dude that isn't used up, right? This is called your ER, your excess reagent. Okay, I have one question for you right now before we move on. And think about it carefully. Do I ever make this much? Do I ever make 11.96 grams of product?
No.
Okay, expand.
Because you just told us, well, we just solved that it's the limiting reagent is sulfur, and so you're gonna get to 8.5 before you get to 11.96. So there's no way you could get to 11.96 since the reaction involves the limiting reagent, which stops before the excess reagent.
Right. It seems pretty dumb, but it's good that I ask it because you're right. You can never get to 11.96 grams because you only, with this much, if you start out with 4 grams of sulfur and 6 grams of chlorine, you will never get 11.96. So what does that mean? That means that after you've done this equation, this calculation, and you figure out who the limiting reagent is, you can discard, and I literally mean throw it away, do not look at it or use it anymore. that other equation you don't use anymore because you never actually make it. It's like if you're asking, and I said this in the first section, let's say you want to make sandwiches, right? But you only have 3 slices of ham and 2 slices of cheese, and each freaking sandwich involves 1 slice of ham and 1 slice of cheese. How many freaking sandwiches can you make? You can only make 2. You can't make 3, right? So you never get to make 11.96 grams. So you forget about it. Once you know that that's not what you're making, you forget about it, because every other part of this type of calculation, of this type of question, you're going to do from this reaction, from this calculation, that number, all that has to do with this part. So that is, you have found out who your limiting reagent is, and you have also found out the answer. This is your theoretical yield of that reaction. In theory, if everything went perfect in lab and you started with 4.06 grams of sulfur and 6.204 grams of chlorine, you should theoretically get 8.5479 grams of product, in theory, right? But that's in theory, and that's if you're perfect, and no one's perfect. So you don't actually get that, but that's another part of the problem. So you understand that we don't have to do anything extra. So theoretical yield is the same answer as you finding the limiting reagent, the amount that the limiting reagent makes. Do you understand that?
Okay, so you said that whenever we're finding either one of those, they're the same thing as each other? So like the theoretical yield is the same thing as the limiting reagent?
Yeah, the theoretical yield is the same digit, same answer as the answer that you get from the limiting reagent, because that's telling you how much you're supposed to be making. In theory, you can only make 8.5479. That is the theoretical yield of that reaction.
I just have a comment. So, another way to reason about which one is the limiting reagent is to just apply the conservation of mass. So when you add 4 and 6, you can't get 11 because it doesn't create matter. So you wouldn't, but never mind. If that confuses you, never mind.
So there are other ways. You're right. There are other ways that you can reason, and you can actually, but it deals with it. Actually, you would have to compare it to moles, because you lose things sometimes in gas, Justin. And
Right, you lose things, but you can't gain them.
okay, but that's actually, you're absolutely right. You're absolutely right. But there could also be, I mean, you don't want to you do not want to get in the habit of using grams as the unit that you're justifying for your product or for your limiting reagent. You know what I mean? But you're right. In theory, you are right. You can't make more than 10. So how can you get 11.96 if you don't even have that much starting material to begin with? But I don't want anybody else to get into the habit of using grams. Like, you should really just think about moles always, and do your reasoning and your justifications with moles. Okay?
Okay.
But you're right. You're right. So it is 4:30, so we don't have time to finish like in the first section, but at least this will get you to a good spot when you watch that quick tutorial tonight. You won't be completely lost. That's the whole point of a limiting reagent problem. You have to figure out who's the guy that limits the reaction going forward. You also have to know what theoretical yield is. You also have to know how to find percent yield, but that's just, I mean, we're almost done. So it's just another step. We'll go over that tomorrow. And then the hardest part of these type of problems is figuring out how much excess reagent is left over. It's not hard, but it seems to be the hardest one that students don't get. So we'll do that tomorrow. And I actually do an example of it in the quick tutorial, but it goes fast. So if you guys don't have any questions.
I have a question.
Go ahead.
It'll probably have to wait until the study session to be answered completely. But what if a reaction yielded 2 products?
It's fine. If you have a reaction that yields 2 products, then you would select actually I did that in the quick tutorial. You select a product that you want to go to, right? So unless they tell you how much whatever is made. If they tell you specifically how much of this is made, then you would go with that product. But if they don't tell you and they just want to know, you know, which one is the limiting reagent, you can go to any one. Any single product, doesn't matter, but both of, or everybody, all of the reagents have to go with that person. Does that make sense?
Okay. Yeah.
Yeah. Any other questions? Okay, so study session tonight at 7. Hope to see you there. If not, we are going to be doing a POGL tomorrow, more than likely. And then we're finished. We are done with chapter 4. No, not chapter 4. We are done with chapter 3. We are done with chapter 3, so we got to get ready for chapter 4 because our exam is coming up, dude. It's coming up soon. Cool. Thank you, guys. If you don't have any more questions, you can go.
Thank you. Have a good day.
Thank you. You too. Bye.